address is wanted to route packet to its destination. But when file is not a part of any directly connected network, okay, so ini akan berlaku. Di dalam itu picture kan, dia tunjuk punya static route macam ni. Di bawah sini. Router A sebenarnya nak pergi ke network ni. Okay, so itu IP address kan 30.1.2.0. Actually is this one. Okay, so this is the destination. But okay, the next hop, okay, sini ya sebenarnya next hop. Ini ya next hop. So the next hop, they actually point right here. So ini ada sedikit masalah. Because the router A kan, dia nak pergi ke tempat sana. Tapi kan, to router A itself, dia sebenarnya tetap mana sini. Okay, this is the next hop. The next hop supposed to be the interface that directly connected to you. Okay, cannot be using the remote IP address. When you do this one right, then high chances kita punya router A kan, dia tak boleh ping ke 30.1.2.0. Okay, it will fail. The reason because you are using the wrong next hop. So sekarang, kalau itu route yang ada dengan sini, kita tak boleh pergi usik. Okay, you cannot touch on this static route. You have to keep it there. So how to actually solving this problem without removing this static route? Okay, so this is the meaning of the route recursions. So, dia punya cara yang macam tu. Okay, you can still keep your destination. Okay, this is where you want to go, right? So this is your destination. Okay, this is the destination. Then the 20, this one. This. So this is the next hop. Ini ialah next hop. So, tapi for kita punya router A sini kan, dia langsung tak tahu macam mana pergi ke sana. Sebab kalau saya nak pergi ke sini punya next hop, saya perlu faham macam mana pergi. Kan? So, on the router A kan, how we going to help the router A? Because if you never add a new route to support it, the router A will lose the connection to the destination. So that's why, sini kan dia pergi tambah satu route. Dia cakap, okay, IP route static. Kalau kita nak pergi ke 20.110. This one. Okay, 20.11. Okay, so we're going to put one more right here. Okay, sekarang kalau nak pergi ke sana, you punya next hop ialah 10.002. Sini. Okay, you should look for this one as your next hop. So ini ialah cara route recursions. So recursion kan dia boleh tolong you fixkan itu next hop punya problem. Okay, next hop punya problem. So you can see that right now, if I want to go to the 30.1.2.0, okay, I suppose need to look for this next hop. But the problem is I don't know where is this. So that's why kalau saya nak pergi ke 20 kan, kalau nak pergi ke sana kan, sebenarnya I punya next hop ialah 10.002. Okay. So end of the day, that means if I want to go here, this is the destination, right? If I want to go to this destination, my next hop is actually this. This is my next hop. Okay, so you boleh nampak punya. So this is called the route recursion. Okay, so this is another level configuration for the static route. Okay, kita tak boleh cakap ini sejenis configuration. This is maybe is one of the static route issue lah. Mereka configure itu routing kan. Mereka use the wrong gateway. So you hanya tolong mereka correctkan itu next hop saja. Okay, so you can using the route recursion to correct the next hop. Okay, then seterusnya here. Equal cost route. When there are equal cost route in the IP routing table, a router for IP packet to be sent to the destination subnet through all valid outbound interface. And the next hop in the equal cost route achieving loop balancing. So, sekarang, kalau you configure static route, kalau sekarang kan, ada dua port, dua interface, dengan IP yang tak sama, 2011. Okay? Another one is 30.1.1. Okay? So, with the same cost. With this kind of configurations, sebab mereka punya cost sama, then you punya packet kan, dia akan loop balancing. So, you will loop balance and forward to router B. So, this is called the equal cost route. Then the next one, how about for floating route? Okay, floating route ni apa? Okay, let's look at this basic concept. Different preference can be manually configured for static route. Therefore, you can configure two static route with the same destination address or the mask, but different preference. Okay, and the next step to implement the backup of falling path. So, ini ialah sejenis kita panggil flooding route. So, flooding route you pun boleh cakap ini sebenarnya ialah satu active, satu backup. A backup route is known as the flooding route, which is used only when the primary route is unavailable. Okay, kalau you punya main punya route sudah hilang, okay, dia tak boleh sampai, then ia baru pakaikan itu flooding route that's installed in the IP routing table. Okay, kalau primary sudah unreachable. So this is the flooding route design lah. You boleh nampak. Okay, B dan C sebenarnya dua router ini kan pun boleh tolong hantarkan paket pergi ke destination sini. Okay, dua-dua pun boleh punya sebenarnya. So depend on how you actually configure it. Okay, so you can actually choose which one is your primary and where is your secondary. So kalau gunakan static route, sekarang kita pakaikan static. Okay, Huawei punya standard preference is actually 60. Okay, 60. So default, saya letak sini ya, default. Okay, default is actually 60. So if you want to making here 10.1.2, pergi ke sini, ini yang primary kan. If this is a primary, dan bawah sini secondary. Ini for backup kan. So if you never touch on the preference, dia akan triggerkan equal cost multipath. So now, if you want to have the flooding route, what should you do, right? The primary, you can using a default preference, 60. And then on the backup route, okay, this one, right, you just increase the value, okay, increase the preference. So now after they compare, 60 versus 70, the smaller one is more preferable. So with this priority adjust, the router A will choose the B as the next hop. Okay, to actually choose here because of the preference. Okay, the flooding route example. Okay, for the switch, so you boleh configure itu default route, point ke router B dengan gunakan default punya preference. Okay, so kalau ini priority lagi tinggi kan, daripada yang lain punya path, di dalam routing table ia hanya tunjuk yang primary saja. Backup punya tak tunjuk. When your primary link here sudah down, kalau sudah rosak, then itu secondary punya yang backup punya ia baru boleh pakai. So sekarang router A kan akan guna router C as the next hop. If the primary link is already down, ya sekarang email traffic akan lalu di sini. And then you can see the preference is actually 70 because previously when I show you the command configuration, they adjust the path selecting the router C, the preference is 70. No, then this is CIDR. So the CIDR is just doing the aggregate. Okay, it's a short for the classless inter-domain routing. So you perlu hafalkan ini like how you actually doing the address summary. So in another word, dia macam VLSN punya reverse version, reverse punya versions. So CIDR dia tolong kita aggregatekan semua IP address jadi satu. Kalau you compare dengan VLSN kan, VLSN variable length and mask. Satu subnet, you perlu bahagi untuk multiple punya network. Okay, so that's called VRSN. Tapi for CIDR, dia tak sama lagi. Sekarang CIDR dia nak gunakan semua IP yang ada dekat sini kan, jadikan mereka become one network. Okay, they want to summary. So this one is called the CIDR. Okay, then they get out the conclusion here is the network address for all those 4 subnet is 192.168.8.0. Okay, so maybe you're not very sure that how does it work actually. So this one, what is .8.0? Okay, we do this one by one. We convert into the binary. Okay, I just covered the third one we do. Okay, 192.168, no need to bother. Okay, we don't care the 168. So the 12, 0, 0, 0, 0, 1, 0, 8, 1, 1, 0, 0. Correct? 1, 2, 4, 8. Correct. Okay, this one is 10, right? 1, 0, 1, 0. And then this 9, 1, 0, 0, 1, 14. 8, 4, 2, okay, 40. And you can see all those binary, right? Okay, I convert the third octet here. Okay, the number is different: 12, 10, 9, and 14. Okay, after convert jadikan binary kan, ini macam tu. So you akan notice sebenarnya all the binary here, they got 5 bit is the same. Mengapa saya cakap sama? Sebab yang hadapan sini 5 nombor kan. 00001 is all the same. Tapi bit nombor ke-6 sudah tak sama lagi. Okay, so that's why I will not check on the 6 bit. Okay, yang ini saya tak pergi check. So paling penting yang hadapan sini. Okay, the front one. So now look at this. 00001 ini sebenarnya apa? So kalau saya letak ini 00001. Belakang sini semua saya letak kosong lah, sebab network address kan. Nah, saya berikan network address sini. So hadapan sini 5 bit sudah fix punya. Okay, 5 bits.
Longest match.
Yeah, so sini yeah, that's why. Yeah, max again, right? So this is 8. Okay, nampak tak? Ini 1 di sini kan, 8. That's why now you get this answer. 192.168.8.0 and 21. Hey, 21 ini dari mana? So sebenarnya kalau you masih ingat, hadapan sini sudah ada 16 bit, 16 bit. Then campur dengan 5 bit belakang sini, 5 bit. 1, 2, 3, 4, 5. So sini ialah 16 bit. So 16 plus 5 equal to 21. Okay, so ini ialah CIDR. Okay, kita perlu tahu macam apa itu aggregate. When you want to summarize the IP address become 1. So this is the formula. what? Okay. Background of route summarization. Summary division and the BRSM resolve. Auto. It's actually auto mover. Let me check. Auto. Yeah, no idea. Route summarization. Some divisions resolve ways, but also bring a new challenge. Increase the routing entry in the IP routing table. Okay, some of the router, right, they can't able to store too many routing table. Simpan terlalu banyak. So we actually hope that is it possible to summarize all the route to save the memory? Okay, that's also possible. So you need to know how to calculate the CIDR. So by giving the example here, the router A sebenarnya dia ada connection ke semua LAN daripada dot 1 sampai dot 6. Semua pun connect ke router A. Tapi A kan nak advertise kan itu IP pergi ke router B kan. Adakah router A perlu advertise banyak kali? Okay, total of 6 IP like this. But actually it's not necessary. If you actually know how to do the summarization, router A kan tak perlu pergi advertisekan setiap satu route. Sebab semua itu IP kan, ia pun boleh aggregate. You know how to aggregate? 1, 2, 3, 4, 5, 6, 7. You just take out this. Okay, so I just put 192. Okay, we don't care about the first two octet. So 1. This is 1. It is 2. It is 3. Right. 6. Now it's 6. Ada 6. 1 sampai 6. You nampak this is a binary for octet ketiga. Dan seterusnya, I perasan that sebenarnya di hadapan sini kan semua bit yang sama. Sini pun ada 5 bit, 5 bits. So now you almost can get the answer already. So how I actually write the network address here if I want to aggregate? So I will put 192.168.0.0/21. Okay, ini saya punya jawapan. Mengapa 21 sekali lagi? Sebab the front here is already mentioned, right? 16 bit. Right here got 16 bit. Dan lepas tu sini 5 bit. Ini ya octet ketiga. Yang ni 1 sampai 6. Okay, octet ketiga. Sekarang kan yang hadapan sini ada 5 bit yang sama. So 16 bit plus 5 bit equal to 21. So this is the network address. Okay, so this is how we actually summarize the network. And now for the IP route technique, kita pun boleh gunakan route summarization untuk simplifikan kita punya configuration. The route summarization is the approach of summarizing a route with the same prefix into one summary route. Okay, in order to minimize the IP routing table size and improve the device resource usage. The router summarization uses CIDR to summarize network segment with the same prefix into a single one. Okay, so ini kan mungkin I boleh tunjuk di dalam saya punya ENSP. Okay, I'll try to show you there. Summary conversion. This is the calculation. I think just now I also did. Okay, let me share the routing loop. Okay, ini pun penting juga. Sebab kalau you gunakan salah kan, nanti kita punya route ada loop. Okay, what is the loop right here? Di sini kan you pun nampak router B belakang sini ada satu, dua sampai 10 kan. So lepas tu router B dia cakap apa? Ini saya boleh default route. Apa yang saya tak tahu kan? I akan pass ke router A. Router A ialah saya punya gateway. Sebab dia belakang sini ada internet. So the B will point the router A as a gateway. Then on the router A sini router A dia pun ada configure ni. IP route static 10.100.16.12.1.1. So that's mean ini router A kan, dia boleh sampai ke sini semua IP address. Okay, after we already adding this static route. Tapi cara macam tu buat itu configuration it will actually cause and trigger the loop as well. Okay, mengapa loop akan berlaku? Sebab macam ni lah, kalau ada sesuatu IP address yang saya cuba ping kan, okay, sini router A. Okay, router A dia cakap, I nak pergi 10. Like this one. Okay, I want to go there. Okay, because I got this one. The server told me how to go. I should look for router 1 if I want to go to look for this subnet. Okay, because it's the same. So unfortunately on the router B, the router B, they don't have this IP address. They got this one is the network address, but they don't have any of this address. So what happened to the router? Okay, the router B here, they also configure 1. Okay, so this is the default route. The next route is router A. Okay, so you nampak ini sebenarnya ada loop here. When the router A, you say want to ping right into network, if this IP doesn't exist, 10, 1, sample ini IP address sebenarnya tak exist punya. Dia hantar ke router B kan. B sini dia cakap, I tak tahu siapa yang top 2, tapi yang laki I got the default route. So I will send this one back to the A. Inilah. Oh, so ia akan hantar balik lah sebenarnya. Okay, it will send back. Okay, so this is the reason why they will generate the loop. So macam mana pergi eliminate ini loop? Okay, sebenarnya di dalam router B, you sudah fahamkan that router A akan gunakan static route point ke sendiri. Okay, point to sendiri to prevent the routing loop. What they did, they go to the IP route static 10.100.16. No. Okay, so this is my static route here. So with this configuration, this is the black hole. Okay, it's a black hole. When the router A send this one to the router B, right, and the B check already, I don't know what is this network for. It will going to choose your yeah, they're using this one. Okay, you can see that this one, they actually send to the router B. In the B, right? Okay, now you want to go to this destination, right? No problem. I'll throw you to the black hole because I don't have the route go to the 10.122. I only got the network address. If they have the user still at this zone, then of course you can ping. Okay, accurate route summarizations. Okay. Yeah, so di sini you boleh nampak B and C. Asing-asing pun ada sendiri punya loopback. Dia ada dua, 172, 1610 sampai 31. However, this summary route also include. So dia create ini 16. Dia ada satu nombor belum isi lagi. Okay, router A. Okay, I don't know where they actually point, but anyway, this one's 10002 mean you're going to point to router B. And then this is the network address 172.16.0. Okay, the 0 behind here is missing. So kalau guna sini ya, that means semua itu IP address hanya lalui router B. So this configuration is actually wrong, fail. Okay, the next here is a summarization number 2. So they show you how to doing the conversion. Understand the send bit and the difference bit. Okay, we're using this key point to actually do the summarize. Okay. So I'll back to my static route here. Okay, I hope everyone is actually ready for this. Okay, now the router 1. The router 1 belum boleh ping ke 192.1.3. Okay, then now it can ping. Because the router 1 have no route, go to the router 3, look back. Okay, dia tak ada. So do you know, okay, now just want to test you that. Do you know this loopback IP address, right? We can actually aggregate these 3 IP address become one. Do you know how to summarize these 3 IP address? So what is the IP and what is the prefix should I use for the Sunday mask? So you have me to calculate this for these 3 IP. So if I want to aggregate these 3 become one, so what is the address should I give? Do you know the answer?
2.
So it's 2. 192.168.2 like this, or 00. This one. Okay, so yeah, it's actually 22. So how I know it's 22? Because you look at this third octet, 1, 2, 3. So you tukar ia jadi binary dulu. 0. So you found that, oh, in front here, they actually have 6 bit is the same one. Ada 6 bit yang sama. Okay, kali ini ialah 6 bit. 6 bit. And hadapan kan, 192, 168 sudah ada 16 bit. So you actually add, okay, sini ya, hadapan. So 16 bit in front plus the 6 bit from the octet number 3. So you get the answer, 22. Okay, so we actually can using .0.0.22. So now my configuration on the router 1, right? Kita boleh buat good into summarize. So you just put IP route static. You tak perlu pergi tambah one by one. Okay, no need. So you just put 192.168.0.0.22. Okay, terlupa itu next hop. Okay, 112. Okay, my configurations. So after enter this to the ping test. Tak ada masalah. Okay, so this is the CID. Okay, how to actually summarize your IP address become one. So kadang-kadang you tak perlu pergi gunakan semua itu route yang ada kan for static route. It's not necessary. If you know how to smaller the size. Okay, so sekarang, I hope everyone is already done this. Okay, I will do the Wireshark on this interface. Okay, so many of the people sometimes they actually didn't realize the problem is, okay, the static route is actually look like very normal. Okay, then many people feel that yeah, static route is just a very basic the IP routing protocol, and I don't think so they got any trouble even that I don't know in deep of this configuration. As long as I know what's the next hop, what's the destination, then I can master the IP static route. Okay, mereka ingat sangat senang, tapi sebenarnya is that so? Okay, is that true? Okay, let me show one of these example. Sekarang, okay now, kalau router 3 kan, you cuba ping 111. Tak ada masalah, you memang boleh ping, ini betul. Sebab I adakah itu static route, dia boleh bawa saya pergi ke destination. Okay, no problem. This one everyone should know. Ping request, you pernah nampak kan? Ada request, ada reply. This is normal. Okay, good. So now sekarang apa yang saya sekarang tengah buat? Saya pergi ke router 1 sini kan. Interface E000. Okay, you coba shut down ini. You try to shut down this interface. Shut down. So you can see the dot right here. They'll turn from green into the red color. Sebab saya sudah shut down itu interface, tak pakai lagi. You tengok, I punya static route, saya ada itu default route, and the router 3, router juga ada apa? Router juga ada banyak itu route. Okay, ini. Okay, dia pun ada static route, tapi ini bukan default route. Dia pakai 10.1.1.0. Okay, so everything still the same, no difference. Okay, kan sekarang saya punya scenario ialah, what if my router 1, the interface here is down? What will happen to this network? you boleh faham apa akan berlaku lah. Did anyone from here who actually configured the static route before facing this issue? You ada pernah jumpa masalah macam tu tak? Okay, kalau you pernah jumpa kan, can you tell me that what will happen if this interface is down? Apa akan berlaku? Yeah, based on experience. Okay, I just want to see how many of you know about this. Yeah, you can also put your answer in the chat box, okay, if you know. Okay, if you know, so everyone can get this. So, what will happen if the interface on the R1 is faulty? Okay, please explain what is the reason. Okay, mengapa ini akan berlaku? So, kita nampak itu routing sangat perfect. Okay, so many people dia tak pernah pergi fikir kalau satu hari saya punya device kan, mungkin you tak pernah buat macam tu lah. Okay, so ini you boleh imagine, ini yang saya punya core. Boleh you punya core switch, pun boleh you punya core router atau firewall. Okay, di sini ialah kita punya distributions. Distribution switch, and this is our access. Okay, this is our access. Okay, nampak macam senang kan? Access pergi ke distribution, distribution pergi ke core. That's why you nampak dia ada itu default route point ke core. Saya punya router one sini kan, saya pun ada itu route pergi ke core punya. Okay, tapi sekarang saya punya network sini sudah down. Kalau access punya area sudah down, apa akan berlaku? So I think maybe it's quite challenging, right, for these questions. So for those who actually experienced before, okay, so maybe you know, or maybe you don't know. Okay, some people will feel that, yeah, I saw this problem before, but I don't know what's the reason. Okay, mereka pun tak tahu. Okay, let me review the answer. Apa akan berlaku kalau itu link sudah down? Okay, sekarang jangan pergi tengok router sini lagi ya. Router one sini kan, jangan pergi tengok lagi. Okay, sekarang punya masalah ialah di antara distribution dan core router, antara dua ini. Mereka punya routing ini kan akan createkan loop. Sekarang you boleh imagine, if router 3 nak ping, kalau router 3 dia cakap, oh sekarang I nak ping ke 10.1.1.1, boleh ping tak? Dia akan hantarkan itu ping packet pergi ke router 2. Dia akan hantar ke router 2. Sebab apa? I ada static route. So dia cakap, kalau saya nak pergi ke 10.1.1, I perlu pergi jumpa router 2. Okay, router 2 dia cakap, okay, so you are looking for 10.1.1.1, but okay, sorry this interface is already down. So down punya. So that's why router 2 dia cakap, saya punya routing table tak ada 10.1.1, langsung tak ada. Tapi nasib baik, I got the default route. I ada ini. So Itu default dia cakap, kalau ada apa benda yang I tak tahu, saya boleh forward ke router 3. Nampak tak? 10, 2, 2, 3. So in this case, what we call this? Ada loop. Sekarang sudah ada loop. Network punya loop. So let me show you. Tadi saya sudah buat Wireshark kan? Okay ya. Sekarang saya tangkap itu paket lah, Wireshark. So saya gunakan router 3 kan? Tengok, you have to watch carefully. Saya ping sekali saja. Minus ialah apa? Saya hanya nak ping satu kali saja. Okay, 10, 1, 1, 1. Hantar satu ping. Tengok apa akan berlaku. Enter. You nampak sini tak? Request timeout. Tak boleh ping. Okay. Tapi di Wireshark sini kan, what is this? Di Wireshark sini, apa dia cakap? Time to live exit. Balik ni. Lepas tu saya tengok, wah, saya keep scroll up. Do you saw that? I keep scroll up. Wow. Semua pun daripada 10, 2, 2, 3 nak pergi cari 10, 1, 1, 1. From sini ya, dari sini. Okay, sini bermula. Kan? Sini kan sebenarnya saya punya TTL value ya. Tengok belakang sini ya. I punya TTL sebenarnya 255. 254, 253, keep turun. Go now. You can see until the TTL become 1. Okay. Finish. Sorry, no more TTL can transfer. Mengapa ini akan berlaku? Mengapa semua pun ping request tak ada reply langsung? Why they got no reply? So ini adalah sebab mereka keep I send to you, you send to me. You send to me, I send back to you. So that's why they have a loop already. Kalau network ini sudah now. Kalau network ini tak down, router 3 ping ke router 1 memang boleh. Tapi if this interface is down, while you are correct using a static route, the big problem is come. Okay, let me undo shutdown dulu. Okay, saya bawa balik itu interface. Okay, now back to normal. I use my router 3. Okay, I just do the normal thing. Tengok. Boleh. Okay, tak ada masalah. Mereka hanya tahu yang sangat beginning dengan level saja. After they done the implementation, what they can see is just a current connection. They never think about in the future. Okay, in the future, what if the network is faulty? Can you actually predict what is the possible problem will come out? So this is only happening for those of the very experienced engineer, or maybe those of the junior level engineer who actually with a very high level to design the network, they actually know. Okay, but normally people, they actually didn't realize about this kind of the problem. So that's why now I'm going to tell you the solution. Okay, now I should have predict what is the problem will be happen in the future. Okay, kalau links ini down, I will have the routing. How to prevent? Okay, how to prevent? Inilah satu soalan sini. Okay, let me review the answer here. Kalau you nak solvekan itu routing loop punya issue. Okay, we do this one together. If you want to prevent it, so sekarang you tahu router 3 sini, dia gunakan IP route static 10.1.1.0 kan? Dia point ke router 2. Router 2 downlink ialah 10.1.1.0. Kalau ini out, tak ada masalah. Tapi macam tadi yang saya cakap, kalau ini down, you are the problem. That's why untuk prevent any case, so what should we do? IP route static, okay, sama. You buat ini 10.1.1.24. Description. Saya ada description. Okay. Description. Okay. Okay, don't worry, belakang sini optional saja, tak perlu letak punya. But it's just to let you know, okay, why I doing this one. 10, 110. That's mean if the R3 they want, okay, sekarang saya pengen lewat sini, so down again, galau. This is down again. Okay, when the network is down, the R3, right, they want to ping to 10.1, you will send to R2. R2 dapat kan, dia akan pergi tengok, oh sekarang you nak pergi ke 10.110, okay, saya tengok saya punya routing kan, saya ada ini, tapi kan ini saya cakap no zero. That's mean apa? Ini sebenarnya I akan hantar ke black hole. Black hole mean I will discard. Okay, I will never send you back anymore. Okay, so with ini command kan, you boleh selamatkan you punya network. Okay, I think maybe you want to see how to prove it, right? Okay, let me prove this one for you. See the result. Okay, now I'm going to shut down the interface again. Okay, I will shut down. Sekarang saya shut down. Tengok ini ya saya punya WiSHR. Tadi saya punya ping semua okay punya. Ping request reply pun ada. Request and reply semua perfect. Now, when this is actually done, the loop might become back. Mungkin akan balik. So, router 3, sekarang saya cuba ping. Sekarang kan saya ping sekali saja. Tengok. Enter. Okay, request sama kan. What happened di dalam WiSHR? Nampak? Dia tak ada banyak kali repeat. Itu TTL dia stop dengan mana? No response found. TTL stop di 255. Dia langsung tak balik lagi. Okay, mungkin saya buat macam ni ya. Saya ping, just normal ping. Ping 10.1. Okay, ping. Nampak? Dia gerak. Okay, do saja. Nampak tak? Nah, stop. Dia tak pergi repeat banyak kali. It will never repeat many times. Because right now the router 2 is already kill the loop. Sebab saya sudah create itu black hole. Okay, so bila kita nak buat macam ni, okay, when we actually need to configure this one, only, okay, a bit sorry it's a bit laggy now. Okay, when should we actually do this one? Okay, kita perlu buat macam ni. Create a static black hole on a device configured with the static deferral. So kalau saya ada itu deferral ini dia memang ada banyak masalahnya. Okay, many people they actually never realize about this. So deferral dia sangat senang configure kan. Semua accessories, semua distribution switch pun boleh pakai. Tapi mereka tak pernah fikir, what if kalau saya dengan downlink sudah down, you actually generate the problem to us. Okay, dia memang ada masalahnya. So kalau you nak eliminate kan itu loop, you mesti create a black hole. No zero. Ini ialah black hole. So ini dia boleh tolong you solve kan itu routing loop punya issue. Especially for the big network. Okay, medium to the big, you need to do this. Okay, so I hope all of you have no problem on this, the configuration for the static route. Do shut down. Okay, I'll bring back the connection. Now they can ping as usual again. Okay, I hope everyone have no problem on this. Okay, I assume everyone is already okay. So then the next one. So the next topic I'm going to introduce is the OSPF routing protocol. But before that, okay, I want to explain about the IP routing protocol. Okay, so I will actually show you this kind of the map for you to compare all the routing protocol. Okay, so ini ya mereka punya connections. Yang tadi saya pun ada explain kan for IP routing protocols, especially for static. So I think that you're already more familiar about the static now. So they got the route static, they got the static default route, and they also got one is called the black hole. So black hole ini kan sentiasa akan bundle together with the static default. Okay, dua ini selalu together punya. Ramai orang selalu gunakan itu static default route, tapi kan mereka tak pernah pergi gunakan black hole. Okay, sebab mereka ingat kalau saya sudah ada default route, mengapa saya nak pergi care about the black hole? Okay, so inilah adalah satu sebab mengapa no matter how they actually try to solving the broadcast down the looping problem, right? The network always have the loop. Okay, mereka tak tahu ingat. Okay, sebab for itu packet punya looping kan, you tak dapat trace. Okay, you tak dapat trace punya, sangat susah. You only can imagine how the traffic is actually forward. So that's why just now I just show the solution. Okay, then another one. Selain derivative static kan, kita punya routing protocol pun ada dynamic punya. Okay, dynamic. So mean they will actually do the calculating, build the routing automatic. Tadi I tunjuk punya static kan, apa benda kita perlu buat? You have to know where is the location of the destination, and also where is your next hop. If I want to go somewhere, then who should I looking for? Okay, that's the static. Tapi untuk dynamic kan, I don't care. The dynamic, once you enable, the router they will start to talk. The device itself, they will start to form the communication. So you're asking and request the route automatic. So dia akan pergi cari punya. Kalau you sudah enable kan itu protocol, dia akan cuba tanya, hey neighbor, may I know what is the IP that you got? May I have your IP? So they will actually automatically exchange the information. So that's an amazing part for dynamic. Okay, very reduce kan engineer punya workload. Okay, then for dynamic, sebab this is computing by themselves. Dia mereka sendiri kira mana satu ialah best kan. Okay, for static kan kita boleh pilih kan, where is my next hop. Tapi untuk dynamic macam mana pilih? Okay, dia ada dua method. First, tengokkan distance. Another is called link state. For the distance, first dia akan carikan path. Path ini ya dia sangat susah nak pergi cakap. Ini macam satu autonomous system, satu AS. Or maybe you can call this is a one country. Okay, one country connect to another country. So this is called path. Okay, one AS to another AS. So biasa PGP akan guna ini. Then for hop, berapa next hop dia akan jump ke berapa device. Ini ialah RIP. Ini RIP stand for the routing information protocol, bukan rest in peace. So this is the RIP and one of the legacy routing protocol. They will help us to do the calculating for the route. Okay, then link. Distal method pun ada sejenis link. So dia tengok you punya connection. Okay, dia sama dengan itu hop, tapi kan link sini dia ada cost sendiri. Okay, dia ada cost. You boleh modify punya. So ISIS is part of this. So ISIS kan dia boleh tengokkan berapa link, okay, berapa itu connection kan sebelum I boleh sampai ke itu destination. I will base on the cost and then selecting the path. Tapi at the same time kan ISIS pun boleh based on the bandwidth. So mana satu path kan yang paling laju? They provide me the better bandwidth. So if this link is a high speed, right, I would prefer the high speed connection. So the ISIS have two selections. Ini lebih is quite similar like the Cisco EIGRP. Okay, lebih kurang. Then OSPF is so you can actually check all those difference. Okay, so this is the routing protocol. So this is your car. Okay, great. It's a very nice car. Okay, so give you the logo. Okay. Last of the car, they have the logo in front. Okay, nice. It's like the view. Okay, so this is from your home. And this is a destination, right? Okay, I just put this is the office. Okay, so from your home, go to the office. Path A, path B. Sini you boleh nampak. Okay, the distance for path A is only 10 kilometer. And this is 20 kilometer. So when you want to go to the office from your home, you drive. Okay, so if you use the path A, the distance is only 10 kilometer away. While you are choosing the path B, the distance will become 20 kilometer away. So based on the distance concern, then normally we will actually prefer the path A. Okay, even for me, I'll choose a path A. If you just look into the distance, so that's why for the dynamic routing protocol, they got this. Okay, they got a distance vector. Sebab dia pun tengok distance juga. Okay, the nearest device, okay, I mean the shortest path will be the best for me to reach a destination. So dia hanya tengok distance. Tapi kalau itu path kan, saya pergi tambahkan sikit info dalam. Okay, itu info apa? Okay, okay, I'm going to include the speed inside. So I think everything will be different now. So if I give the selection for you, okay? So now you are actually from home, you want to drive to the office and you got two paths to go. You can choose path A and path B. So which path you are going to use? I will still go for the path A or you use the path B. Remember, path A is 10 kilometer, path B is a 20 kilometer, but the driving speed is different. So this one you have to look carefully. This is a speed. So now, which path you guys are going to prefer? I will still prefer the A because of the short distance, or you actually prefer the path B? So
For the speed, is path B.
Correct. Yeah, for the speed concern, right? Of course, we'll be choosing the path B. Correct. Yeah, even for me, I was still doing the same thing. Sometimes it's not about the distance problem, okay? Okay, because if let's say they have no traffic problem, right? So the distance will be the first concern, right? We prefer the short distance with the best to us. Tapi kalau sekarang kan, itu tempat kan, you selalu driving and you faham, it's always got traffic jam. It's always have the traffic. So no point for me to go there anymore. I know the path A is very short, but there always traffic jam. But the path B, what's the good thing right here? The path B, right, I know it's actually quite far away. It's like almost double than the path A. Tapi apa? Path B kan, saya boleh drive dengan full speed, 80 km per hour. That's mean, berapa lama saya boleh sampai office? I think it's only 15 minutes. Tak sampai setengah jam pun, you sudah sampai. Okay, kalau guna path A berapa lama? Ini 1 hour. 1 jam you baru sampai ke office. Itu distance hanya 10 km. If you choose a path B, wow. I think 15 minit sahaja. So I think this is quite common happen in the Jakarta there, right? The capital. Sebab tiap-tiap hari kan, when actually reach to the peak hour, when you want to drive to the office or you're leaving your office, go back to your home, you have to spend a lot of time stuck in the traffic. I think at least you have to start like half an hour or maybe an hour. Okay, I'm not sure how long that you guys going to take. Okay, so yeah, this is a problem right here. So based on this concern, right, now you know which protocol will be the better to use. Okay, kalau you pilih yang itu hop cow punya, yang itu distant punya kan, then recommended protocol ada RIP, ada BGP, ada ISS pun boleh. If you are the guy who actually concerned about the bandwidth, the speed, connection punya speed, you boleh pergi pilih ISS atau OSPF. Okay, so you can based on this one and consider which protocol will be the best for you. But I can let you know that the common use one. Sorry. Canvas. Okay, so I will do some explanation here for the routing protocol. So the most common use place, the application, the scenario. So BGP, the most common use in the ISP. Sebab ISP kan service provider selalu ada itu routing kan connect ke lain punya country. We will have the cross stage, cross region, cross country connections. So the ISP will like to running the BGP. Because of BGP, right, they're full of the policy. They can control what is a route should advertise and what route should not advertise. Okay, so of course, the Datacom HCIA tak ada cover ini. Ini untuk IP level ke atas. For RIP, Routing Information Protocol, suitable for SME, small, medium, enterprise. Okay, small until the medium enterprise. So mereka pun boleh pakai RIP, tapi ini ialah legacy punya protocol. Now dia banyak yang pun tak gunakan RIP lagi. Sekarang replace dengan OSPF. Okay, so the OSPF is very suitable for the campus network. Okay, can be the university, even for ISP pun boleh pakai. Semua enterprise pun boleh guna. Okay, so that's why I put the campus network, OSPF. So this is actually suitable for all kind of scenario. Then untuk ISIS, is very suitable for data center. Mengapa? Sebab ISIS kan, dia ada banyak additional feature. So you boleh pakai untuk macam MPLS, TE, you boleh pakai untuk VXLAN punya feature, dan ISIS punya itu update sangat cepat. Okay, it's actually very fast when you compare to the OSPF. Okay, it's actually super fast. At the same time, they support link and the bandwidth calculation. Dua dia pun support. It's like hybrid. To the service provider, the data center, mereka actually looking for these two. So that's why if the data center is actually using the Cisco equipment, they will go for EIGRP. But if the data center is not using a Cisco equipment, they will surely go for the ISIS. Okay, mengapa? Sebab Cisco itu EIGRP kan, ialah proprietary for Cisco device. Okay, other vendor mereka tak supportnya. So that's why when the data center is not using the Cisco, using other vendor one, right, they share is running ISIS. Okay, so this is the introductions for the routing protocol. Okay, routing protocol, safe. Okay, if you get like this one, you also can do the print screen. So in the future, you can use this one for your reference. Okay, so the time now is already close to the 2:30. So we were just taking the short break. Okay. After the break, then I'll come back here and continue. The next one is the OSPF. Okay, I'll come back after this.
Mr. Roy,
Yes, I'm here.
can you share your Zoom file for us, like
Oh,
training
but
before?
this place I cannot share. I don't know how to share. Because the chat box right here only Microsoft SharePoint.
Okay.
I can reopen the screenshot picture for you guys. So maybe you can just take the screenshot, I think.
Or can you upload it for Google Drive or something else?
Google. Okay, yeah, I will try. I'll find the way to share out the resource. No problem. Yeah, so later I'm going to share out the link in the chat box so you guys can click and download.
Thank you, Mr. Roy.
Okay.